Hi everyone, it's John with Prudential Lighting. Today we're going to talk about a new product family of ours that we just recently released, and I'm really excited to tell you about because it changes almost everything for us. And it is something that we call our BionicPro. Now, you're familiar with our Bionic. It's been out for a long time. It's our recessed linear product that obviously has linear versions as well, and perimeter and the whole family. The BionicPro, however, is a completely redefined version of that thought. And obviously the question is, well, why a completely redesigned version of it? And honestly, because over the last handful of years, there's been enough change in technology, enough change in material sciences, enough change in optical development and industry expectations about what sources can do and should provide that we really needed to start from scratch. And so if you're going to start from scratch, which is what we did, we said, well, what is it that needs to have, and how are we going to define this? And obviously it needs to be a complete family. It needs to be what we'll call minimal in a sense of its interaction with the built environment. It needs to be very clean and very simple and elegant, and we'll get into that in a little bit. And then we have some technology that we're going to add to that from the optical side. You know us a lot for our optics, and we are not going to disappoint on this new product either. We have something that we call TrueBeam. And then obviously all the tech side of our world now. So it has to interface with all sorts of designs and control systems, and we're going to do all of that. So if you take a look at our family though, our existing family, we had a couple of apertures. In this case, we've grown it, we've expanded it. We needed something that was tech zone compatible, of course, and that's a 4 and a 6, obviously, from a tech zone. We needed something that sat in between those two, and then we needed a smaller aperture because obviously smaller is what the industry wants. And so we have these 4 apertures. All right, so the next thing about this family is it needed to be what we called minimal, and that meant a couple of things. The fixtures themselves needed to blend into the environment as seamlessly as possible. If you're familiar with us at all, we have a family that we call our Stream family. That doesn't have a lens, but it appeared like it did, and so it created this effect of a seamlessness all the way through. And in that case, we were using a reflector that also was very long, and we didn't need to chop it at all, and so it created, even in the off state, a seamless approach, and everyone loved that. In this family, though, we're bringing a lens back into the fixture because we're going to use it, as you'll see in a second, but we also wanted that to be seamless. And so what we did there was to use a seamless lens, there you go, that comes on rolls. And these rolls can be as long as 250 feet. And so we do not have now snap-in lenses. The beauty of that is that we don't have any of the gaps at the seams of those lenses as they butt together. There's no light leak there. And historically, always at the end, even if those lenses butt together well, which they often didn't, but at the end, we had a flat plate against which we had to snap this lens in as snug as possible and yet leave some room for lens expansion, contraction, and therefore light leak was kind of built in. In this product family, we have gone away from a flat end plate. Even if it's in the ceiling now, it's a cast end plate. And that casting allows us a pocket, if you will, for the lens to go past the end and to guarantee that we do not have any light leaks even at the ends. Okay, so our trims is the other part. When you look at a recessed linear product, right, the only thing you really see are 2 things. You see the lens, you see the trims. And we want to keep the trims just as seamless, if we can, as the lens to make this feel like it's really blending into the architecture well. And so in order for us to do that, there's 2 places we're concerned about. One is when the fixtures come together, we need to pull those tight, make them align, make sure that it seems like there is no seam there, or as minimal as possible. And then at the end of the fixture, normally what you would do is you'd have a flat end plate, and the trims would simply come and stop right here, and then I'd have a flat end plate, and people would say, that's fine, I've got a T-bar, nobody can see it anyway. And we'd say yes, but it doesn't really play as well as we'd like. What we'd really like to do is see this trim continue all the way around as a single piece. And one of the ways we're going to do that is we're going to mount these together before we ever send them to the paint line. They're going to get painted together and on. And so not only are they in perfect alignment, but the paint is going to end up covering any seam possible. And so it's going to look like it is a one single piece with no cracks, no seams, and make this seal feel real. Okay, so we've talked about the expansion of the family. We've talked about keeping it minimal. Those things were expansions and evolutions, if you will, that were a little bit gratuitous and we needed to do. The industry expected them. But what we were really looking for was something that was not evolutionary, but revolutionary. And we wanted that to come at the level that we are known for, and that is at the optics level. Obviously, you're familiar with many of our other products, our Microwash, Microcove, our Bionic, our P43. All of those products have great optics, have won awards. That's what people know us for. And yet we needed to do something totally different here. And we needed to do it for a couple of different reasons. For one, the existing optics are all extruded. And when you extrude things, well, first of all, the lens has to snap in, and we want to get rid of that. And secondly, the size of the prism that we're able to extrude, given that technology, is only so small. It's a 40,000th of an inch, actually. That's as small as we can make them and hold it. And that prism size is too big for people who are looking at a lens and hoping it's going to feel soft, like it was just an acrylic, and yet give us the optics, which is what everyone has been asking for. Give me great optics, but I want the lens to appear soft and like it's just an acrylic. And that's a problem, obviously, in our existing technology. And so what we have done is come up with and pioneered something that we're going to call TrueBeam technology. And it is enabled using our lens roll technology. And what we're able to do, and what we've figured out how to do now, is to take those prismatic structures that we need to bend light, because you do need them, and to shrink them so small that you cannot see them except under magnification. And when you do that, when you look at the lens, especially if those prisms are symmetric, the lens appears to not have any at all. It appears like it is a soft acrylic lens. And yet, because we have now really thousands of prisms, so what we've done is we've shrunk them down to somewhere in the 10 micron level, which means that within one of those prisms that we currently could do at 40 thousandths, I can fit almost 100 prisms inside of one. That's how small we're talking. And so that technology is a completely different way to design, is a completely different way to manufacture. We are not extruding acrylic any longer at all. In fact, we're not using acrylic even anymore. And there's a couple of benefits to this. One of the benefits, which is actually quite large, is because I have so many prisms now in the lens, I have unfettered myself from needing the reflector portion to do its part of the work. Now, all I need is for the reflector to shuttle as much light that's generated as possible down to the lens itself. And we're going to let now our plethora, our exponentially greater number of prisms now do their work. So that unfettered us from this mechanism, or that paradigm, which we don't have to do anymore. So the beauty of that is also that it allows us then to create different optics, all at this lens level. Obviously, all of these that we're showing here, without a change of reflector, because the reflector doesn't play anymore in that outcome. All it's doing is shuttling light to it. So you say, so what? Well, the big so what here is that means this particular fixture is every fixture, and all of them all at once. And you say, so what? Well, so what means now I don't have fixtures that are specific to the perimeter or to the middle of the room or to the wall wash areas. I don't have to worry about which way the fixture was put in, because now I have a reflector. In the olden days anyway, up till today, we had a reflector that was aimed kind of off asymmetric. Easy enough to put in backwards, pain in the butt to fix. If you got into an installation now where that was the wrong fixture, now we're talking multiple trades potentially if they're mudded in. We're talking time, we're talking money, we're talking all sorts of bad things. And so this unfettering of the reflector from the lens is actually a gigantic enabler for everyone in the supply chain. And then the second thing, which we kind of touched on just here a moment ago, is because I have so many prisms available to me, I can do, first of all, a better job in my distributions. Right? If I have 50 or 100 times as many prisms controlling elements, I should be able to do a better job of creating an idealized distribution. And in fact, you can. So the distributions will be better. That's one great benefit. But the second great benefit is, again, not tied to here. All the work being done here means now I can create lots of radically different distributions just by the prismatic structures that I put in the lens, which are now completely interchangeable. So if you've got a perimeter fixture in a bathroom with tile, and the tile guy did really, quite frankly, a crappy job, and the architect walks in and looks at that and says, no, I hate that, switch the fixture. We're not switching anything except taking out the lens and putting in the other. And that is going to be super enabling for everybody. That makes it very simple and very powerful as a tool for all of us. So what I'd like to do now is show you some of these different distributions and how they work and what the function of them is and why in the world would you want these different distributions. So we're going to go take a look at that. Alright, so when you're designing, you've got design build space and you're looking at open offices, we offer a number of lenses, and that's the beauty of the system. And those lenses give you different distributions, and in this case you care a lot because if I'm in open space I want to use as few fixtures as possible, spread them out as wide as possible. So what we're looking at right now is a traditional satin acrylic lens, and we're pretending that the fixture is, well, it's 5 feet away from what would be the workplace, the work plane, and in this case a desktop. And so what we see from a couple of things. One is I've got a fairly bright section right here, right underneath it. I'm looking at about 79 foot candles here, and as I step away, I'm down to 19 on this side. And you can see that it's the beam itself goes only to about here, and then I start to get into the field. And so if I were to switch that though and go away from my standard acrylic to my Batwing lens, now you can see I've got a lot more brightness happening here. I don't have that shadow that's started to creep in right here. In fact, it's way off here. And how we've done that is we have choked the middle. And so my foot candle levels here are now down to 49 or 50. And they have raised, in this case, up to 32. Same distance, same fixture, same lumen output, same everything. All we've done is change lenses. So if you're in an open office, this guy will keep you from ordering too many fixtures, and you'll be save on labor, you'll save on fixtures, you'll save on time. That I don't want to throw as wide because I'm going to end up with light on the walls, and people don't want that. So we're going to use a soft sealing wash in that case. And obviously Lambertian in both up and down if you'd like, and then an asymmetric sealing wash from the perimeter as well. So a really robust offering in terms of optical choices. Okay, so you can understand now why we called this a revolution and why we needed to start from scratch. We have changed so much of this from what it was now to really industry-leading ideas and concepts, from bringing seamless lenses into this long built environment to a completely new approach from optics, giving us way more control than we ever had in any one individual optic, and giving us way more optics than we ever offered before, and then creating a really simple way to interface with this, whether you're a contractor or anywhere along the supply chain. We call it BionicPro. We hope you'll use it. We hope you'll specify it. We hope you'll love it.